Hello, my name is Hailey Bjerknes. I am a third-year student here at Cal Poly Pomona, and for my technology presentation, I will be talking about aeroponics. So to start at the beginning, what is the technology? Aeroponics is a specialized version of hydroponics, where the roots of the plant being grown only extend in the air, and the roots are directly sprayed with a nutrient water mix instead of being submerged in water like in hydroponics. So at the bottom is a clear picture of the difference between the two. Although aeroponics is part of the hydroponic family, the two are completely different. In the hydroponic method, the roots are grown in oxygen and nutrient-rich water solutions, and the roots never leave the water except to be processed when they are done growing. In aeroponics, the roots have the freedom to gather as much oxygen as they want with no restraint. This surplus in oxygen helps accelerate the absorption process of nutrients and create a healthy plant root stock, and produce significantly faster crop growth rates. There are actually two types of aeroponic systems that I'm going to get into today, but just to reassure the listeners, the two are completely different methods. The first system of aeroponics that I will be talking about today is called the high pressure system. Now, this system generates a fine mist of water droplets that are the optimal size for encouraging nutrient absorption and plant growth. So remember, the roots are exposed in this system. So as you can see in this illustration, it is quite dumbed down, but there is a graphic image about the nozzle spraying directly onto the roots, and the roots are suspended, allowing oxygen. They are not completely soaked in water like hydroponics. And what is commonly used as a pump is the reverse osmosis pump. So there are several components to this system. There is an enclosed root growing chamber with the frame that holds the plants on the top. So that is the box that you see. There's a high pressure water pump. So in that case, what's commonly used is a reverse osmosis pump. And so this pump pumps the nutrient-rich water through a misting head that produces the fine mist that is then sprayed onto the roots. There's a pre-pressurized accumulator tank, a pressure relief valve for the accumulator tank, an electric solenoid, a precision relay timer, spray misters, tubing, a reservoir for collecting excess nutrient solution. So the nutrient solution is the water. And now there's like a lot of parts in this system, but it is what makes it work so well and why it is out of the two the best working aeroponic system on the line. So we have a few pros and cons for this high pressure system. So like I mentioned before in the last slide, this is the most efficient aeroponics method because it uses little water and the roots absorb almost all of the nutrients instantly. It saves water because of the nutrient reservoir. The water is constantly circulating and pumping back and forth and using the nutrient-rich water to be sprayed on the roots. A good example of this is in the image at the bottom. That is showing the suspended roots with the little clay mesh balls holding the root ball. And what is happening in that image is the pipes are circulating the water and the misters are spraying the roots. So the high pressure aeroponic system has been proven to shorten growth cycles in plants by 25% or more. This precision method of nutrient delivery allows for better absorption of the nutrients, improving root strength. So this method, the high pressure method, gives off very tiny drops of water that makes it easy and accessible for the root mass to absorb the nutrients that it's being given. So some of the cons is that it demands an expensive upfront setup cost. It is pretty expensive to get one of these systems because of the high pressure technology that is needed for the misters to do their job. Root disease is most commonly occurs when the root chamber isn't kept at the proper temperature. That's why there is a temperature sensor. The image at the top is a tiny little diagram that shows like how active root temperature control is important for the faster growth cycles. The misting heads may get clogged occasionally by mineral particles in the water. That is why there's supposed to be routine maintenance done on these systems. And also it requires a learning curve, so it's not beginner friendly and lots of technical pieces. So your labor force has to be skilled in this system as well. Moving on to our second system, this is called the low pressure system, also referred to as Aeroponics. So in this system, the plant roots are suspended in the air, just like a regular aeroponic system, but they may be partly in contact with the nutrient mix in the accumulator. This is where the term Aeroponics comes from because of the way the roots look, because the low pressure mixtures can only produce a light spray, kind of like a tiny sprinkler, and not a true mist like the high pressure nozzle. So this system is the most common for home growers who are just starting out and don't want to invest in the high pressure setup. The system uses a pump, sprinklers, and a reservoir, and a platform for plants in an enclosed root chamber. So a lot of the time, first starting out aeroponics growers will use this technique because it is low maintenance. It doesn't cost a lot to start up. You can literally use a 5-gallon bucket and have a little system. The diagram at the top is a lot simpler than the one before, and just has a few components compared to all the components in the high pressure system. And so for the best results, each spray should be aligned upwards to spray above the roots so that each spray from the nozzles overlaps slightly. You want the spray to create a fine mist and then let the water run down from the top of the plant roots to the bottom. And then it all trickles back down into the reservoir. So that is the way you can get the best use out of your nutrient mixture. So a few pros and cons of our low pressure system. Some pros are that it is simpler, cheaper, and less technically challenging to build and maintain other than the high pressure system. It is more efficient than non-aeroponic type of hydroponics. So in case you don't want to invest in the high pressure system, you can at least do the low pressure system and you're still probably getting a more efficient yield than the hydroponic system. And then pump failures can lead to crop failure if not monitored regularly. If those roots dry out at all, you're going to lose your entire crop. Some cons: uses more water due to the large water droplets that hit the roots and then drip back into the reservoir, so the mist isn't as fine. Root disease is the same. The same thing applies to this system, that the root disease is the most commonly occurs when the root chamber isn't kept at the proper temperature. So that is why a temperature sensor might be needed as well in the low pressure system. And it is slightly wasteful on nutrients because of the water droplets, like I said before. The roots can't absorb it as fast as they can the fine mist. So moving on to the mist size, this is where it all pays off. This is where the two systems are completely different. The high pressure aeroponics system has more of a fog-like mist that is 20 to 50 microns in size. So as you can see on the left-hand side, that is the fine mist from the high pressure system, and that is what is sprayed onto the roots. And then the low pressure aeroponics has more of a spray of mist that is a larger droplet size. So the low pressure nozzle looks more of like a little sprinkler that you would see on regular base grown plants, but that you can see a little root hanging down there on the right hand side. That is what is used in a low pressure nozzle system. So how does this technology work? I know I went through two of the systems and two of the aeroponic systems that are most commonly used, but how does the technology work overall? So these plants are held in a large vertical grow racks or other racks that can successfully house the plants. So there's a few examples on the left-hand side. Essential organic liquid nutrients such as nitrogen, phosphorus, and potassium are added to a large water reservoir, which then is irrigated/sprayed directly onto the root ball of the suspended plant. The seed of the desired plant is planted in pieces of foam stuffed into tiny pots, which are then exposed to light on one end and the nutrient mist on the other. The foam also holds the stem and root mass in place as the plant grows. So in each one of the little compartments, I'm looking at the top left in the little barrel, and each one of those little compartments is a foam block that is holding the plant that is suspending the roots into the tube. And there's a little inside look in one of those tubes at the bottom here. So those little pots sit there and the pipe is down the center and there's nozzles spraying to each side. The root chamber is an enclosed container like those pictured that needs to keep light out as well as pests while keeping humidity in, yet also allowing some fresh air in to enter so the roots will be sure to have plenty of oxygen. The need of a temperature sensor is a must. Going back to the root decay, that is why a temperature sensor is a must. So how is the technology used? These aeroponic systems are used to cultivate plants without the use of soil matter. This technology can be applied in almost any setting of farming because it leaves the option to expand the farm space horizontally and vertically. It has been estimated that aeroponics farming requires 98% less land when compared to their traditional counterparts. This technology can be used to grow many types of plants, including microgreens, leafy greens, herbs, strawberries, tomatoes, and even cucumbers. And the list goes on, but these are just a few. And a fun fact, NASA saw the potential in using aeroponics by the late 90s, and by the late 90s, NASA had began using it as a way to growing food in space, which is awesome because no soil, no problem. So getting into the costs and savings, we're talking about the financial stand of things. The cost of an aeroponic system varies. DIY models can be made for less than $100, but good quality professional systems with automated nutrient monitoring and a backup power supply start in the low four-figure range. And that is where your high-pressure systems come into play, the big dogs. So for a high-pressure system, the most expensive part is the misting pump, which ranges from $1,800 to $2,500. The tubing, which it's high pressure rated, can be $1.50 a foot, and other irrigation parts can range from $3 to $50. So DIY systems can vary in price as well, depending on what pump you get. Cheapest one I found was on Amazon for $25. You can probably find a cheaper one. And so it also depends on what type of grow unit you choose. You can choose a 5-gallon bucket, a big old blue barrel. But for example, if you want one of those fancy dancy towers, that holds 28 plants per tower, seven stackable modular sections. It can cost about $500, or you can just build your own. And then artificial lighting systems, water bills, temperature control systems, and fertilizer are other costs associated with growing aeroponically. But in savings, after the large buy-in, aeroponic systems usually require little maintenance except for fertilizer/nutrients being added into the nutrient bath. And the system can grow plants throughout the year without any interference. It is a plant growing system that is both environmentally friendly and cost effective. And shown below is what a high pressure pump looks like. It kind of looks like a deep fryer to me. But I bet once it's wired up with all the high pressure nozzles, it looks better. So on the labor side of things, on a typical farm, plants growing in the soil, labor is a huge part of the sector. Most of the labor in both systems of aeroponics is a labor that takes to set up the system and maintain the system. Labor must be highly specialized and trained, whereas with geoponic ground farming methods, high-skilled labor is not a necessity in the day-to-day operation of the farm. Training costs time and money. One of the most significant factors is the cost of access. This refers to the time spent getting to crops, whether it be walking between aisles to tend to crops or riding scissor lips up and down the rows to harvest them. Cost of access in part of the financial aspect plays a part in financial aspect of cost and savings as well. In order for labor to be successful and complete their jobs, equipment must be accessible, meaning growers need to buy it for their labor force to succeed. If the cost of access is given to the labor forces, and now this is on the savings side, productivity will increase and lead to more crops being harvested and cared for in a day. For social costs and savings, the main cost is when it comes to social savings is just the cost of the aeroponic systems in general. There is a lot of savings. A single unit takes less than 6 square feet and uses stackable sections that can hold 4 plants each. And the aeroponic growing process produces up to 30% greater yields, 3 times faster compared to traditional farming methods. And for most herbs and leafy greens, the seedling to harvest cycle can be as short as 21 days. And so I thought this image was pretty cool here on the right. There looks to be multiple vertical farming techniques being used to see growing food. And to see growing food in an urban environment such as a baseball field is really cool. I see some of the towers in the back, and there's a few other little methods that I thought was really interesting. On the ecological side of things, for cost and savings, the use of artificial light instead of sunlight can relate to an ecological con, and same with creating an artificial growth habitat with no soil. For savings, though, by growing crops off the ground, you reduce the risk of soil-borne pests and plant diseases, and since each tower grows independently, you can isolate and address any issues that do arise without jeopardizing your entire farm. So each little system is quarantined by itself. So no fertilizer and pesticide runoff into our waterways like traditional farming, and aeroponic systems use up to 98% less water than conventional farms, which is especially crucial for those growing in drought-stricken regions, such as California. So some of the ethical costs and savings that on the cost side, it's a loss of market for traditional farmers. Moving to the aeroponic system, hydroponics, whatever kind of on land growing without the use of soil is the loss of a market for a traditional farmer. On the savings, it promotes ethical farm growing by using less resources and in return getting a higher yield of crops. And it can be used in urban settings as a way to produce more food and promote healthy agricultural practices. So who is the technology used by? It is used by large-scale plant/produce production companies, and they usually use the high-pressure system. And they can use this technology as well as your everyday gardener, most likely to use the DIY low-pressure setup, looking to get better plant yields with less time being spent gardening in the soil. This technique can be used in many different settings, such as community gardens in urban areas, in large warehouse settings, and even your own backyard. The large warehouse setting greenhouse is the image on the background. Those are the big old towers growing, looks like lettuce. And then the small backyard production is a big blue barrel, and it has several different portals to allow different plants to grow into. And then what problems does this technology solve? So this aeroponic method of growing paves the way for sustainable agriculture. With less space required and higher crop yield, the aeroponic growing system makes an ideal farming method, especially in highly populated urban areas. The aeroponics growing system produces a yield 3 times higher. Without soil, the plants are healthier and carry a richer flavorful profile. And then up to 95% less water than outdoor farming is what these systems is. This is what the system has. It benefits the system. And no pesticides or harmful chemicals are used. And there's fewer food miles and reduced carbon footprint when using at-home growing methods. And then no fertilizer runoff into the waterways. Thank you for tuning into my presentation. These are the few of the citations that I use, and I hope you have a great day.